Gas giants like Jupiter, Saturn, Uranus, and Neptune are colossal, swirling behemoths. They're thick layers of clouds concealing mysteries that have captivated scientists for centuries. The mere thought of life existing in these chaotic, storm-ridden atmospheres feels like the stuff of science fiction. Yet surprisingly, the question of whether life could survive in the harsh, alien worlds of gas giants isn't as outlandish as it seems. Before we delve into the possibility of life, we need to grasp the formidable conditions that define gas giants. Unlike Earth, gas giants don't have solid surfaces. These planets are composed mostly of hydrogen and helium, with traces of methane, ammonia, and water vapor swirling in their upper atmospheres. The deeper you descend, the pressure skyrockets, crushing anything that dares enter the lower layers, while temperatures soar to unimaginable extremes. Jupiter, for example, has winds that can reach speeds of 360 kilometers per hour, with storms like the Great Red Spot, a swirling vortex larger than Earth, raging for centuries. Temperatures at the cloud tops are frigid, plunging to around minus 145 degrees Celsius, while deep within, the core might reach a searing 24,000 degrees Celsius. Saturn and Neptune aren't much better, equally violent, equally inhospitable. At first glance, these conditions seem to annihilate any hope for life. How could anything survive in such a tempestuous, volatile environment where temperatures shift from bone-chilling cold to molten heat, where there's no ground to stand on, and the atmospheric pressure would crush the life out of most organisms? But life, as we know it, has a remarkable tendency to find a way. The idea of life on gas giants might sound preposterous, but let's focus on their upper atmospheres. Specifically, the layer between the hellish depths and the freezing outer reaches. Here, temperatures are less extreme, possibly ranging from minus 40 degrees Celsius to 50 degrees Celsius. In such a temperate zone, some scientists speculate that life might exist in a suspended drifting state, not too different from life on Earth. On Earth, life is incredibly resilient. We've discovered extremophiles, organisms that can thrive in boiling hydrothermal vents, acidic pools, or even radioactive wastelands. So, why couldn't certain forms of life adapt to the extreme yet stable environments in the clouds of a gas giant? Imagine an ecosystem not anchored by gravity to a solid surface, but instead free-floating, suspended in midair. Some researchers have entertained the possibility of life forms that could exist as gas-filled balloons, floating within the turbulent atmosphere. These hypothetical organisms, which might resemble jellyfish or even microbial life, could drift through the planet's atmosphere, using the available chemicals to fuel their existence. One intriguing concept involves aerial plankton, microorganisms that could drift through the air, collecting energy from the sun through photosynthesis, much like plants do on Earth. These organisms might absorb nutrients from the thick, chemically rich gases around them, like methane and ammonia. A more bizarre idea is the existence of large, balloon-like creatures, akin to floating bags of gas that could control their buoyancy to hover at optimal heights. These beings, adapted to thrive in the gases of these planets, might feed on the chemical soup around them, floating through the endless cloud layers of Jupiter, Saturn, Uranus, or Neptune. Energy sources in the atmosphere. One of the key requirements for life is energy. On Earth, energy primarily comes from the sun, but in the dark, dense atmospheres of gas giants, sunlight is scarce, particularly as you descend into the deeper layers. However, there are alternative energy sources that could sustain life. Jupiter and Saturn, for instance, emit more heat than they receive from the sun due to the slow contraction of their immense mass. This internal heat could provide energy for life forms in the deeper regions of the atmosphere. Lightning storms, common in these turbulent clouds, could also serve as an energy source. The violent flashes of electrical energy, far more powerful than those on Earth, could spark chemical reactions that support basic forms of life. And there's methane, a substance found in the atmospheres of many gas giants. On Earth, some microbes known as methanogens thrive by consuming methane and releasing energy. If similar processes could occur in the clouds of a gas giant, this might be another pathway to sustain life. However, life on gas giants wouldn't look anything like life on Earth. The organisms adapted to these environments would likely be radically different, built to survive in a world where gravity is crushing, and the only source of stability comes from riding the winds. Earthbound concepts like solid ground would be meaningless to these creatures. Even their biochemistry could be unrecognizable. On Earth, life depends on carbon and water, but in the dense, frigid clouds of a gas giant, alternative chemistries might be at play. Life could be silicon-based instead of carbon-based, or rely on liquids like ammonia instead of water as a solvent for biochemical reactions. In such a world, life might be so alien that we would barely recognize it. One of the biggest challenges of the search for extraterrestrial life is detecting it in such alien environments. Space agencies like NASA and the European Space Agency, ESA, have sent numerous probes to the gas giants, Pioneer, Voyager, Galileo, Cassini, but these missions primarily focus on atmospheric data, not life detection. The difficulty lies in the fact that any life on a gas giant would be fleeting, existing in narrow, specific layers of the atmosphere. Probes that dive into these planets, like the Galileo probe that entered Jupiter's atmosphere in 1995, are crushed by the immense pressure before they can reach the potential habitable zone. Future missions would need to hover at just the right altitude, sampling atmospheric gases for signs of life, such as unexpected levels of certain chemicals like oxygen, methane, or ammonia. Despite the intrigue, the idea of life existing in the atmospheres of gas giants is still speculative. There are numerous challenges, not the least of which is the fact that these environments are wildly unstable. Constant storms, lightning strikes, and high radiation levels make it difficult for life to maintain a foothold, let alone evolve into complex forms. For now, the question of life in gas giants remains open. It's a tantalizing possibility, one that invites us to rethink our assumptions about where life can thrive. Could there be strange alien creatures floating among the clouds of Jupiter or Saturn, invisible to our telescopes and probes? Or are these planets truly the barren, storm-racked giants they appear to be? In the search for extraterrestrial life, nothing can be ruled out. As we continue to explore the cosmos, we may one day find the answer, hidden in the very skies of these distant, forbidding worlds.